Lesson 14.5, Probability Simulations. You've probably messed with this before. You need to understand the difference between theoretical probability, which is based on entirely on math, and experimental probability, which is done out in the real world. So, what's the likelihood I roll a 4 with a 6-sided die? Well, if I just go with theoretical probability, there's 6 sides. 4 is one of them. They're each likely to happen. I get 1 out of 6. I played with this a little bit. If I go with experimental probability, I think I just did 16 tosses, 18 tosses, and I got 4 out of 18, which is 2 out of 9, which is not too different than that. It's a 0.22, and this was 0.17. Those numbers aren't that far off, but you can see they're different. How do we get them to be more alike? Well, we do more tosses. If assuming our math is correct, the experimental probability should eventually catch up. But some people will ignore the experimental probability and say, well, the math tells me this, so you have to be smart about it. So this is a simulation that was run with a drug, and they were assuming it would fix people, and they said, you know what, it should fix, that's your theoretical probability, should fix 70% of the patients. So they actually ran 3 studies, and they found that it helped 61%, 74%, 67% in each study, did no improvement to these, and actually made one of them worse. So this is a drug. What's the experimental probability in study 1 that it actually was successful? So we just look up here and we say right here, 61% or 0.61. The theoretical was 70. So those numbers are not that different, but somebody did something wrong, and clearly those aren't the same. If we had to take all 3, we'd have to average 3 in the middle. So 61 plus 74 plus 67 all over 3 equals 67.3%. That's just the experimental. Still didn't match up with the theoretical, but at least we have a general idea. A lot of things that people want to do is say, well, I know something, this is a sidebar, I know something has a 50% chance, I'd like to model that. How do we model? Well, if you're modeling 50% chance, that's easy, just use a coin. A little harder if I say, well, I have a 1 in 3 chance. How do we model something with a 1 in 3 chance? Well, use a die and figure it out yourself. How would you go 1 in 3 on a die? Think about it. So once we get this experimental data, we can use it to predict. Field goal kickers always hit 75% of his kicks. That's 3 out of 4. How many do you think he'll make out of the next 8? Piece of cake. Just multiply. He should make 6 field goals. Another example, Adam raises purebred dogs. One of his dogs has 4 puppies. He wants to know how likely is he to get 2 female and 2 male puppies. Well, there's 4 dogs. Each one has 50-50 chance to be male, female, or at least we can assume that. So there's 2 choices for each one. Multiply them out, we get 16 choices. How many are going to have 2 female and 2 male? Well, that's actually a combination because we don't care if female and male come first. But there's 4 choices and we're taking 2 of them. And that is equal to 6. So the actual theoretical probability is equal to 6 over 16, which is 3 over 8. So that seems a little counterintuitive, which makes sense. It's not always going to be what we think. That's why we blast out the math. 2 female and 2 male, oh, you should say that's a 50% chance of that. Well, it turns out there's only a 3 out of 8 chance of that. It's just not as likely as you think. So he takes a flip coin, like I was just saying before, and he starts flipping it and saying, let's run experimental data and see what we get. So what's the experimental data? There'll be exactly 3 male puppies. He's got 12 that are 3 male. He ran how many data sets? $50. It's 12 out of 50. 0.24. 24% chance. And how does that compare to the theoretical probability of getting 3 males? So again, there were 16 choices, and that would be C43, which is 4 basically over 16, which is 1 out of 4, which is 0.25, which is 25% chance. So his flipping of the coin actually gave him some really nice data. Better than the one I got before. How come? Well, I would guess that he did 50 flips. I only did 18. If I had done that many more, I would have found out, okay, it is better than I think it was. That's it. Get practicing. You're going to have a lot of rolling dice and flipping coins coming up in your very near future. Good luck.